All right. I happen to know how to do this one. It's like I'm a math teacher. All right. I plugged in the same things, and I got the same values, so good job there. Now, use the values from the table above to answer the following question. Given the equation of the horizontal asymptote of the graph of f of x equals x over e to the x. Okay, so they're graphing this, and like at some point, what is the asymptote? Okay, so as well, to find horizontal asymptotes, you take the limit as x approaches infinity and as x approaches negative infinity. So, if we were to evaluate this limit, if we were to think about it, and maybe not even evaluate it, if we were to think about it, we'd take the limit. What is happening? What is happening? We take the limit as x approaches infinity of the function x over e to the x. All right. So here's the way I want to think about it. When someone says something is growing exponentially, they mean it's growing faster than not exponentially. So if the top part is just approaching infinity, and then the bottom part is the exponent is approaching infinity, the bottom part is going to grow so much more faster. The bottom part is going to grow exponentially, by definition. It's going to grow so fast that it dwarfs the top part. So it's almost comparable to 1 over x if you take the limit as x approaches infinity. It's kind of like that. Here, x is getting super huge, and this is small by comparison. The same way, e to the x, e to the infinity, it's going to be super huge, and this is going to be less huge by comparison. And once you get way, way, way out there, the denominator will dwarf the numerator, and then it will tend towards 0. If you ever have a ratio, you're taking the limit of a ratio. You get this in Calc 2. If you ever take the limit of a ratio, if the top part is growing slower than the bottom part, then your limit is going to go to 0. If the top part is growing faster than the bottom part, then your limit will go to infinity. Hopefully that makes sense. Here, we're only talking about going in the positive direction. So as x is approaching infinity, this tends towards 0. So actually the k value, yes, you're right, it will be 0. But to be completely thorough, we actually have to check what the limit as x approaches negative infinity is. So if we look at this side, here we're plugging in a really, really, really large negative number. First of all, that means this top number is going to be negative, right? It's going to be some negative number. And then if we're plugging in a negative number in an exponent, then it's going to move up to the top, right? So really what we're having is e to the, some really, really large number, right? So this is actually going to be negative and then grow exponentially also. So if you're approaching the negative, or if x is approaching negative infinity, there is no limit. It's negative infinity, because if you put a negative in the exponent, it moves it up, and then it just grows exponentially, and the negative in the top makes it grow in the negative direction. So like the graph of this, I think, would look like if you go towards negative infinity, if you go towards the left, you go down to negative infinity, and as you go towards the right, this suggests that we're going or tending towards 0. So something like that. And I'm sure if you looked up the graph, if you Googled the graph of x over e to the x, it'd probably look close. I'm going to Google it just right now. Yep, that's what it looks like. If you plug in 0, what do you get? You get 0 over 1, so it actually crosses there, doesn't it? Yeah, so it actually does look like that. But it comes above the x-axis a little bit, right? Because these are all positive values. But then it gets closer and closer and closer to 0. So that's kind of what it looks like. Hopefully that was not confusing. There you go. Thanks for asking. Bye.